section 9.2, we're going to look at hypothesis testing involving two means. So we'll have a mu1 and a mu2 in our claims. And they tell us that we're going to have independent samples with sigma 1 and sigma 2 unknown, which means we'll have sample standard deviations S1 and S2 instead. Remember, when we have S and not sigma, that we use a t-test or a t-interval. But now we have two means and two standard deviations that we're going to be taking into account. So what we'll be doing instead is what's called a two-samp T. We're going to look at testing first, so let's look at the two-samp T test. And again, the two is to tell you that we're dealing with two samples. The samp is short for sample, and we're using T's instead of Z's because we do not have sigma, we have S. And we're going to look at, like I said, hypothesis testing first. So let's take a look. So we are still going to have to identify the claim first, just like before. Then we're going to have to figure out, where does our claim land? Does it land in our null hypothesis because it has an equal to, or does it land in the alternative? Then we'll have to determine, do I have a left-tailed, right-tailed, or two-tailed? Remember, we're using T's for this, and so we can still use the normal distribution graph. And again, we'll have either a right-tailed, left-tailed, or two-tailed. We can sketch our graph. We are only going to look at p-values. We won't look at rejection regions here, but you could do that. Remember, the p-value is the area in the tail, or if it's two-tailed, it's the area in both tails. So what you can do is find the area in one tail and just multiply it by 2, because remember, these normal distribution curves are symmetric. So whatever area you have in one tail, you will have the same exact area in the other tail. And again, the area will be our p-value. And just like before, when we get to, once we get our p-value, which again, the calculator is going to find for us. How's it going to find that for us? Because we will have it run that two-samp t-test that we were talking about. So it's going to want some information. It's going to want the sample mean and the sample size, just like before, and the sample standard deviation, but we're going to have two sets of all that information. So again, we'll have the sample mean, the sample size, and the sample standard deviation. One set of information. And then we're going to also have a second set, because remember, we are going to have two samples of data. So we'll have a second sample mean, a second sample size, and a second standard deviation. All of this information has to be given in the problem. Okay. So let's take a look at what it'll look like in our calculator. So when we do our two-samp t-test, we'll enter in, you can't see it based on what the printout here is, but see there's a little arrow here. That means we already entered in our x1 bar, that means our sample mean, and our SX1, which is our sample standard deviation for the first set. And then we can see the rest. We can see the sample size for the first group. Then you can also see the second group, the sample mean for the second group, the sample standard deviation for the second group, and the sample size. Then you can enter in whether or not it's two-tailed, left-tailed, or right-tailed based on your HA, your alternative. We're going to always leave this last part where it says, is your data pooled, as a no. So just don't touch that, leave it as no. And then we will move on and select calculate. Just like before when we did this, you'll get two pieces of information that we care about. A T and a P. Now notice, the T will only get used if you do rejection regions, which we said we're really not going to do. So we're going to really focus on the P value here, which is a P of 0. Now they're saying basically that this rounds to 0. It won't be exactly 0, but it'll be really small. And we're going to ask the same question we always have that never changes. Remember, our question is P less than or equal to alpha. Just like before, if the answer is yes, we'll reject H naught. If the answer is no, we will fail to reject. That means we'll list out just like before, our H naught and our H1, and we'll figure out which one of these is our claim and whether or not we're rejecting or failing to reject. And then we'll come up with our final statement. What does this mean in terms of the claim? But again, be careful. We're using T's, not Z's, because we only have S, not sigma. So let's take a look at an example here. On this first example, we have a simple random sample of 13 four-cylinder cars. And we're looking at the data for those. For that group, the mean has a break